Hey Tom, how you doing?
Hey Edwin, I'm doing fine. You guys?
Yeah,
Yeah,
great.
great, great. Glad to have you on our show today.
Yeah, thanks for having me.
Yeah, of course. I guess you want to talk about load testing and then in particular with Azure tooling, right? Is that correct?
Yeah, that's right. So,
Nice.
what I typically see is that yeah, application teams do have some functional requirements, and they are really
Mhm.
good at testing them,
Hmm.
like unit testing, feature testing, all kind of stuff. But the non-functionals are most of the time forgotten, or maybe just done by a simple load test that's done by a tester.
Yeah, yeah.
Maybe once before you go to production.
Yeah.
Um, but
And
yeah,
then we talk
it's
about like
easy.
performance, right? And latency and stuff like that, throughput, those
Yeah,
kinds of
that's
requirements
right.
for your system. Okay.
Yeah,
Oh,
that's
cool.
right.
Yeah, I think you can show us load testing with Azure tooling. So I'm curious. Take it away.
Yeah. So my talk is about how you can get grip on your non-functionals using Azure Load Testing. So when I'm talking about non-functional testing, we usually talk about one of these six types of testing. And today I want to focus on these two in particular. So
Okay.
performance testing and scalability testing. And before I get into what is this, I'm curious about how you guys are currently handling your performance testing or scalability
Hmm.
testing.
We have people for that.
We have people for that. Cool. And how do those people do that?
Yeah, often it is like if you have an API or something that you can call right as a service, then it's just using some tool to hammer that service and see if it buckles under the load or what the performance characteristics are. But I must say, just as you just described, it is often something that's overlooked, that is forgotten, and that indeed once we go to production, oh yeah, we also have to do a test like this. So I really recognize that you talk what you talked about. So
Yeah, same here. So on my current project, we do have a lot of unit tests, acceptance tests, spec flow, stuff like that. And then on the performance side, every once in a while, when we have some major change, we may do a performance test, but that's usually done with some manual tools or custom written tools. And
yeah.
it's not easy to repeat it. So ideally, I would just want to have something that runs maybe once a week or once per day, and just do that automatically for me.
Yeah. So when I think about non-functional testing, it's usually like the system is seen as a black box.
Hmm.
Like we're using testing scripts to run against this black box, and just out of these testing scripts, we get some results, right? The results may be good, may be bad, depending on what your non-functionals are. But they mostly consist on client-side metrics, like a request error rating or the response time of a request.
Yeah.
Um, but what do you do when the results of your black box are bad, right? You want to open the black box and see what's going on wrong and
Mhm.
why it's going wrong.
Right.
But how many of our projects and the projects you guys did and I'm doing, if you open that black box, looks like this? So if you have a performance issue on a request that's handled by several different components in your system, how can you quickly see what's going wrong? You have to look into it, see all the different components by itself.
Yeah.
Is it an infrastructure issue? Is it a code issue? Do you write some algorithm that isn't performing well?
Right.
But getting a view into this is really hard at this time.
So I guess it's also really important to think about the scope of that black box, right? So if you have a microservice application consisting of, I don't know, maybe tens, even hundreds of microservices, what's the scope of your test going to be? Are you going to test a single microservice, or are you going to test a bunch of them together within a single test?
Yeah, and that actually depends on what your non-functional requirement is. So if you have some kind of flow in your system that needs to respond within half a second, then the test that you want to run is the test that covers that whole flow.
Yeah.
Right.
So, but I guess I've sketched the problem here, right? Because when you
Yeah.
have a flow that goes about different components, it's really hard to pinpoint actually what's exactly going wrong.
Yeah.
So when I talk about Azure Load Testing, when I look into this, just to start, it's just a preview feature in Azure. it has some really cool things going on right now, but it's not available in every region yet. So if you want to make use of it, you have to search. It's currently available in North Europe and East US at least. But Azure Load Testing is a fully managed load testing service. So what I mean with that is that the infrastructure that's used to perform this load test is completely managed by Azure. If you use a tool like JMeter or any other tool, you usually have to use some kind of infrastructure that you're performing operations on yourself, and even scale it out if you want to do more than just a simple load test. If you really want to buff your system, you have to scale your infrastructure. Load testing also provides the possibility to use parallel execution, and that in combination with a scalable test engine allows you to really pump up your system. And it collects the client-side metrics that JMeter, for example, also collects for you. So in base, it's actually the same as like a tool for test JMeter or any other performance testing tool. But when you look at why would you choose for Azure Load Testing, and here comes the cool part, is that I'll show you in a sec that Azure Load Testing has some really cool live updates shown on a dashboard that is available in Azure, in the Azure portal itself. You can even keep history. It even keeps history for you on your historical test runs, so you can visually compare your historical results. So yeah, if you made a code change, you can run your load test again, and then you will see if the change you've made impacted your performance. And you're not bound to any Azure-based applications when you want to use it. You can also just run it against any on-premise environment that you want to load test. If you choose to test an Azure-based application, you get much more out of Azure Load Testing, because not only can it collect the client-side metrics for you, but it also collects the server-side metrics, which help you to identify the specific performance bottleneck in your system. And it allows you to fully incorporate with the security best practices from Azure, like networking security or making use of Azure Key Vault. And it even automatically stops your performance test when one of your resources is throttling a request. So if you're incorporating your Azure Load Test with an Azure-based application, you will get much more out of it. So if you look how this is done under the hood, as a user, you'll write your JMeter-scripts. This can be done in a tool like JMeter itself. These are uploaded to the Azure portal. So the test engine then picks up the script and starts executing the test that you defined in your script, and then collects the client-side metrics from that test run. And then ships it to the dashboard. When you're using the Azure-based application stuff, you can also collect the metrics of any Azure application that you're using and its dependencies. So when you're testing your web service that's running on the app service in Azure, you can also collect the metrics like CPU usage, memory usage, and any other metric that you want to collect from that app service and its underlying service plan. So let's have a look at it. This one. So this is the portal that you get when you go to the Azure portal and you go to your load testing resource. And yeah, the first thing you see, it's not really filled yet because it's just a preview feature and it's not very loaded yet. When you go to your testing tab, you have the ability to create a quick test. But before I do this, let me first introduce you to my test application. So what this application does, it's really a simple application. It's a .NET 6 API, which can create a weather forecast by put request, and then it has a get request to get the created weather forecast. So it's really easy get and put request that we want to load test here. When I go to the Azure portal, I go to create a quick test. Then I'll just define my get endpoint in this case.
Yeah,
quick
and that
test.
test application you are using is running on Azure App Services, right?
Yeah, so when I go to my resource group, I'll show you the let me see. Yeah, there's here is my app service, the dotnetFlix site that's running on an app service plan. So when I take my test URL, the getter URL, I have the ability to configure some of the specifics of some parts of the test run that I want to do. So the number of users that I want to use, the duration of the test, and how many seconds it take for my test to be fully firing at my system. So for this test, I just want for the example, I just want a duration of just 30 seconds, and then I'll just click run. So what Azure does is it generates the JMeter-script on itself, a very based low-level script that you can run. But in a second, we'll see that the only, it's really a quick test, so it's not really configurable. So the only request you're able to test is that get request.
And Tom, you said that it also collects server metrics using monitoring. Do you have to already have monitoring, like a log analytic workspace or app insights connected to your application, or is that not necessary for that to work?
No, that's not necessary.
Okay.
I'll show you that in my resource group. Let me go back to my resource group. I don't have any application insights or anything configured. So I'll come back to that in just a sec.
Yeah.
So this is going to execute. I'll come back to this result later. Because the other thing you can do is you can upload your JMeter-script. And what I did is I created this test script in front, so I don't have to bother you with the JMeter interface and how you can create that, because that's really not a very user-friendly interface. So let's create the dotnetFlix test, run immediately after creation. Let's not do that for now. We can choose the JMeter-script that I want to use. Here you have the possibility to configure, to parse in some variables into your scripts, like any environment variables or secrets. And as I mentioned, you can even connect your Azure Load Testing to your Azure Key Vault, so you don't have to enter any plain secrets here. For the load, like I said, you can configure your engine instances, your test engine instances. Because in a JMeter file, you can configure how many threads you want to use in your test. And each test instance can run up to 250 threads, 250 threads. So if you want to use more than 250 threads, you have to scale up your test engine. Then you have your criteria. Your criteria are your failure criteria. So you can select, these are currently only possible for the client-side metrics. So you can select your response time or your error time, the average response time. If that's greater than 300 milliseconds, then just my performance test has failed. Let's not do that for now. I'll come back to that later. Here you can link any resource, Edwin, like you just asked. So if you want to use any monitoring to any resource that you've defined in your Azure subscription, like I did, you can add them right here. But it's not mandatory in front, so you can do it always later. I'll show you that by just continuing. So when I create this test, and I've checked out the box that I want to run the test immediately, so it's just only going to create my test. So if I now go back to my quick test, you'll see the duration was done in like half a minute with 5 users, like I configured. And what you see here is the client-side results of that quick test run. So the duration was 30 seconds. The number of requests that was fired at my system, the error percentage, the throughput, and my response time. And they're also pointed out in the table, so you can have a nice visual look at the results. So for a quick test, if you only have a get endpoint that you want to test, here you have a really easy way to get this going. So when I refresh here, there's my other dotnetFlix test. I won't start this now because the test that I've configured will take up to like 10 minutes, and I'm not really good at talking for 10 minutes and just show you nothing in the screen. So I ran the test in front, like this morning, and I'll show you what the results were of this test. So if my Azure portal will help me with this. Yes, cool. So here's the same view as I showed you with the quick test. Here you also have your client-side metrics. But when I go to my app components here, I'm able to select all the components that I want to collect data from and show them in my dashboard. So I have my app service. I have the app service, the server farm of the service plan where my app service is running on. And this service connects to a Cosmos DB to save and get the weather forecast. So when I select this and I go down to the bottom, I will see all the server-side metrics that Azure generated out of itself without any use of application insights that I configured to show you what's happening in your system. So maybe for you guys, Edwin and Sander, if you see, let's talk about what we're seeing here. So in the beginning, I saw a average request per second of like 60,000 per endpoint, and it slowly decreases in time. Right? That's what we're seeing right here, right now.
Right. Yeah.
On the other hand, we saw that the response time is going up, especially for the GET requests, so for reading data. And the PUT requests also increasing, but not as much as the GET request. Well, that alone doesn't really say much. There can be a lot of things that can be wrong in this situation, right?
Yeah.
So when I go down to my server-side metrics, here I have my Cosmos DB metrics, and here I'll see the total amount of requests that's done to my Cosmos DB instance. So that's really, yeah, that doesn't really tell me much either. The throughput is always the same, so that's not really interesting. My request units that are being consumed are at 100% scale. So this might be a problem.
Yeah.
Not seeing any errors, so the responses don't go slow by any errors. The number of requests, what I see is that my for some reason I have more than 1K requests, but like here above, you can see that my RU consumption isn't really going up. So maybe that's related to the problem that I'm having. CPU usage is, in some point, the CPU usage is going through the roof, but not for the entire test. So there is something that's causing my system to, slightly decrease in performance the longer the test takes. Can any of you guys guess maybe what's wrong with this? If you see my architecture.
Contention on the database, or it's something to do with partitioning in Cosmos DB or whatever?
Yeah, that's a really good guess actually, because I'm not really good at Cosmos DB and I really fucked up this partitioning key, because I only have one partition key where all those requests are sent to.
Really getting a hard partition.
Yeah, but this is not a Cosmos DB talk, so you're excused. There's no problem. It's actually great for showing a load testing tool. So
yeah, for sure. And now, even if you have never seen the code or this demo before, you don't know what I created as a problem. You guys were really good at identifying, hey, maybe we have to look in this direction. Okay. And I think that Azure Load Testing really helps you in finding what are the spots in your system to look at least. Cool. So let's go back to my slides. and I'll show you in a second that it's really easy to integrate your load testing with a GitHub Action or an Azure DevOps pipeline. And what you get out of that is that out of the box, you will get an automated regression testing tool, because you can create a JMeter-script that defines your regression tests, and you can run that in your pipeline. So it's not even used for performance testing or just firing at your system, but you can also use it for testing if you didn't break anything in your code changes. The pipeline is fully configured with YAML, because everyone loves YAML, right? I'll show you also in a second how that looks like. You can define in that configuration any error states that you might occur in your test run, and even define if the test run or the pipeline should fail on that error. So if you see any 500 errors or any other errors that you don't expect, immediately fail your test and just stop your pipeline from running, so you can't even deploy your code to production. And the other thing is the failure criteria that I showed you in the Azure portal like a few seconds ago. You can also specify them as your non-functionals as rules in your pipeline. So you can define a rule for, hey, if my code changes here result in a response time of like 300 milliseconds or more, just failed my pipeline because I have a non-functional requirement that says the result must be faster than 300 milliseconds. Cool. Let me show you how that works. So what I did is I created a really easy GitHub Action pipeline. I'll show you. So what this does, normally you would like to have a build step and a test step and a deployment step in your pipeline, but it's not really for this demo. The only thing I'm doing in this demo is I'm plugging into Azure, and then I'll just start my load test. And my load test is configured using my YAML file, like I just said. So let's have a look at that. In this load test YAML, you can define the version that you're using. Now we're currently in preview, so this is version 0.1. You can define your test. For now, I've called it the CI test, the test plan, which points at the JMeter-script that you want to run. The script I also have here in my source code, so it's not any upload anywhere or so, it's just living in my source code. The description of your test that's shown in the load testing dashboard. Number of engine instances I want to run. And so if I've configured over the 250 threads that I'm using in my JMeter-script, I need to configure my engine instances here. And my failure criteria. So what I'm specifying here is that I say, hey, if my average response time is above the 300 milliseconds, then fail. Or if my error percentage is above 50, also fail. So when I go to GitHub and I'll start this workflow, and then let's wait a sec before this starts. And when it starts, I'll switch back to the Azure portal. Because you can also visually follow your load test running in the Azure portal. So this is going to take a second now. So there it goes. So when I go back to my Azure Load Testing portal, and I'll just click the refresh button here, I see a CI test has come up as well. So the GitHub Action is able to create this test itself. You don't have to configure any load testing environment in front or so from it. It just generates it from the JMeter file that I specified in my source code. And when I look at this, the test run is executing right now. And the results of this test run will be communicated back to my GitHub Action, and the GitHub Action will then determine, hey, is the result according to my failures or my failure criteria, or is it good, and can I go on to the next step? Yeah, let's just wait a few seconds before this finishes, and then I'll show you the results.
Well, one thing that's interesting is now that these metrics are showing up, is this like a real-time view that keeps updating while the test is running?
Yeah, so here in the top you see the auto refresh is now off because my test is done. But when you're running a long running performance test for like 10 minutes or so, you see the metrics here getting updated to almost real time. It's updated on, it depends on how fast Azure collects all the metrics that it uses to define the metrics.
Right.
When I now switch back to my GitHub action, you'll see my pipeline is succeeded. It even defines why it succeeded, because my average response time criteria is met because the actual value is only 38 milliseconds. My error percentage above 50% is met. It's not met because its actual value is 0, so it passes. And for now, these are the only 2 things you can configure in criteria. But I hope and I think maybe in the future that Azure would even provide more possibilities for the failure criteria. Maybe for the CPU usage or the memory usage that's going up when you don't expect it to be. So that could be really cool additions to this feature.
Yeah, you are running this load test from North Europe region, right?
East Europe. No, currently I'm running it from East America, East US.
East US. Okay, yeah. And your app servers, where is that hosted?
Also, everything is hosted currently in East US.
So okay, so everything's in one region, but I guess that's not a requirement to get this up and running, right?
No, all the resources don't even have to be in the same resource group. So when I go to my one of my test runs, and I want to measure the backend metrics, so I can also select, like you see here, it's from other resource groups and other. Like you see, this one is in West Europe. So if your resource, Azure resource, is touched by the test, you can also collect those metrics.
Yeah, nice. Because when you have a really global solution, you might want to deploy multiple of these test environments in different regions, and then see if the performance is met for your different customers all over the world.
Yeah, for sure. But this is actually one I wanted to show you guys for Azure load testing at the moment. Do you guys have any more questions about it, or any thoughts on how this could work for you, Sander? Like you said before.
It could definitely work for me. So I'm thinking about some tests I want to do basically right now for my current project. But I have to really look into JMeter first, because I haven't worked with that yet, I have to say. I know it's Apache license, right? So I guess that's free also, or are there any licensing costs involved with JMeter?
No, you can download the Apache JMeter binaries from the internet, and then you can just start with creating your own script. No any licenses or anything needed before you can get into this.
Okay, cool. Yeah, because I really want to write some tests against an API management environment we've got up and running, which sends requests to some backend functions, all running serverless on the consumption plan. But then for that to work, I would first need to dive into the JMeter documentation to see how do I do a login and do that OAuth dance with API management before I can actually put in the actual request.
Yeah, so Azure Load Testing has some advanced topics where I didn't went into today, but there are some possibilities to manage that authentication part for you.
Oh, sweet.
Yeah, cool. So I'd love to talk about it more with you.
Yeah, we'll definitely talk more about this, Tom. So the other thing that I thought was really cool in your demos is that it's the auto discovery of those application components, and that without really having to specify how your solution is composed, it will just find, hey, you're using a Cosmos DB, hey, you're using this and that, and then show you all those metrics. I think that's really powerful.
Yeah, I think so too. Yeah, like I said, you were able to pinpoint the problem in my system, like from just a few seconds looking at some metrics that you haven't seen before. So I think it's really powerful to use this tool.
Yeah, cool. So thank you so much, Tom, for joining us and showing us all this cool stuff. So to everyone watching, thank you so much, and remember to subscribe if you haven't done so already, and we'll see you next time.